Hi, I'm Michelle Brasso. Welcome to Flexible Physics. In this session, we're going to plan your physics course and help you navigate this next year, whether you're in class, online, or in a blended scenario. A little bit about me. I'm entering my 12th year of teaching physics at the high school level. At my school, students get 1 unit of physics in 9th and 10th grade, and then in 11th and 12th, they can choose to take full physics courses. I have my professional Master of Education with a classroom specialist, and I love teaching physics. I'm such a nerd and I love to have fun in class. So I wanted to share some tips and tricks to help you navigate what could be a crazy year. The question that I'm most often asked is, how do I plan and pace my physics course? Well, when I started way back when, I planned the way that my own teachers has planned. So I started with kinematics. Now that led to some problems for me and my students. Again, my students start a real physics course in 11th grade, and it's a big transition for them from their other science courses. So when they get to me and we started with kinematics, it was really tough for them. The math implications were pretty significant and they needed to have strength in math, science, and literacy. So by the time we got to our parent-teacher conferences, I sounded like a broken record of this course gets easier after this and their marks will go up, and I just couldn't handle any more students crying at parent-teacher conferences. So I decided to make a change, and this is one of the greatest changes I've made in my physics teaching, is switching up the order of units. When 11th graders enter my classroom, they don't start with kinematics anymore. They're starting with nuclear energy. Now that works for me because my students have a pretty good understanding of the periodic table from the chemistry they learn in 9th and 10th grade. And from there, we can jump right into isotopes. It's really not too hard to do calculations with mass energy equivalence. And I've found that not only has the engagement increased, the marks have increased, their grades are higher, and I have better retention in my classes. Since doing this switch, I don't think I've had any students drop because the course was too hard. So that's a big win for me. One thing I want you to consider this year is switching up the order of your units. Yes, it's traditional to start with kinematics, and it does feed into a lot of other units, but is it really best for our students this year? I have a feeling that a lot of students are going to be returning to class, whether it's online or in class, with some deficits in their math. To no fault of the math teachers, of course, but our last few months of teaching just couldn't be as effective as it would have been if we were in class. So, that being said, with kinematics relying on some higher level math skills like trig, cosine law, and sine law, and the quadratic formula, I think it will be best this year if we started with something that was mathematically simpler. What I would suggest this year is starting with speed. Speed is a pretty good entry level math. It's not difficult at all. You can do labs online or in person with speed, and that feeds into a couple other units that makes it easy for the students, maybe a little bit easier for you as well. For example, if you start with speed, you can then go into a waves and sound unit or a light unit without too much trouble and without having to stress the students out too much with the mathematical requirements of that unit. Another option, like I mentioned before, is starting with the atom and working into nuclear energy. That's worked really well for my students in the past, and it's led to great success. If you're not sure, ask yourself these questions. Is this the student's first physics course? Will students have experience with trigonometry, including sine law and cosine law? Will students have experience with vectors? Are you concerned about the enrollment of your course? And do you feel prepared to teach vectors online? After considering those questions, you may have a fresh take on whether you want to start with kinematics or a different unit this year. When ordering your units, think about the best logical way for the units to flow. If we're switching things up this year, then you might have to rework your entire course. But we're up for that, aren't we? We're doing it for the kids, aren't we? Right? Right? Okay, good. So what you can do is use this handy little ordering units flowchart. So if you start there with speed or waves or the atom, you can get into some pretty easy units. And then once your students are more comfortable with your learning management system and with you as their teacher, and with the content as a whole, then you can start introducing those trickier concepts in those larger units. Think about what will serve the students best this year. When you're planning your units this year, it's going to be increasingly important to focus on what your students should be at the end of the unit, less so on what they need to know or do. So when you're planning, you may have heard of the KDB umbrella. That's know, do, be. What should the students know at the end of the unit? What should they be able to do? And who should they be at the end? Yes, it's great if students know how to protect themselves from alpha and beta decay, and it's awesome if they can do a mass energy equivalent calculation. But really this year especially, it's going to be important that students become something. And when I plan my nuclear unit, I always focus on them becoming informed citizens, informed voters. I want them to be able to see the benefits of nuclear energy, how that can really shift the tides in our energy industries, especially if we get to nuclear fusion. And I find that's more important than them being able to do calculations and them being able to, know certain facts. Of course, this is tricky because we have to assess them on what they know and what they're able to do. So we just have to lead with what students should be at the end of this unit. When you're planning your units, think about how are you going to assess your students. If you're in class, it might just be status quo, tests, quizzes, projects, labs, that sort of thing. If you're online or in a blended format, we have to be more creative this year. I would continue to recommend doing quizzes so that students can get feedback on their work. When you're offering quizzes, make them short and sweet. We don't know what situation students are in, so we don't want to give them quizzes that are 3 hours long or quizzes that need to be done at a certain point in time. And I would recommend not giving any grades on these quizzes. The reason there is that they're really an opportunity to learn and get feedback. If they're short and sweet and deliberately chosen questions, you'll be able to give them feedback quicker than if you had a long quiz. So looking forward, what you can do if you're in a virtual format or a blended format, you can actually create quizzes that are designed so that each student gets their own values while testing the same skills across all of the students in your class. One way to differentiate between student work and to try to cut down on the copying between students is to offer questions where the values change based off of student attributes. So for example, you can have a question like, the mass of this block is the number of digits in your house number, and the radius of this circle is equal to the number of letters in your last name, something like that. And we found that worked really well. Just be careful if you have twins in your class, because that caught me a couple times. I shouldn't have, but it did. I really recommend choice boards as you're planning a virtual experience for your students. My students commented every single week that they really appreciated having options for not only learning the content, but for also showing their work. So here's an example of one of my choice boards. You can see that students have different opportunities and different modalities to get their information for this lesson, and they also have different ways of showing me their understanding for this lesson. Students often opted for doodle notes, and I was lucky enough that all of my students had access to a printer in my physics classes. That may not be the case for you, in which case I really recommend trying to get printed packages out to students when they're picking up supplies like their textbooks for this new year. When planning out your learning experiences this year, it might be very different from a typical year. So consider some virtual field trips, some simulations online, and even some interviews. I really like this website called Exploring by the Seat of Your Pants. They're not the only one to do interviews, but I really love the variety of interviewees that they include. They often have people from astronomy, physics, biology, chemistry, ecology, environmentalists. They have a great range of speakers, so I highly recommend you checking out Exploring by the Seat of Your Pants. Switching up the order of my units was one of the best things I did for my student success. The other thing was student workbooks. This has honestly changed the way that I teach. So if you are teaching in class, what I've found is that student workbooks also help us save time. Students aren't writing every single word of the note. Instead, most of the notes can be done in a fill-in-the-blank format, and then students get to work through examples in their workbooks. So it saves time in the sense that you don't have to find your workbook or find a certain page in the textbook, find all the materials. They should have those all out. Another neat thing is that students can transition right into their homework after the lesson, or at the start of class. If you start by taking up homework, then the homework leads right into the next lesson. So again, here you're saving precious minutes in class by just formatting everything together. I'm sure you know by now that labs are a completely different animal this year, whether you're in class and socially distanced or completely online. Here are a few tips that you can use to still incorporate labs in your classroom. The first one is just to continue as you were before. Maybe that means students are wearing masks and disinfecting when sharing materials. The great thing about physics is that you can do it with dollar store items. A neat thing that I've seen on some of the Facebook groups is teachers planning packages to give to their students. And in the package, they get their notes, but they also get lab materials. Little things from the dollar store like string, marbles, a known mass, toy cars, that sort of thing. A simple idea is having students grab a toy from home, it could be anything, and explaining the physics behind it. It could be as simple as a baby toy xylophone and explaining why the keys have a different frequency, or something more complicated like taking apart a toy car or a wind-up toy and explaining how the gears make the motion. A lot of the labs in my class are done in an inquiry format, and it's really easy to get started with inquiry. One of the best ways that I was taught many years ago, actually my first year, was to start with sticky notes. So consider some sort of event like a pendulum swinging. You can ask students to write down on one sticky note something that they can observe, like, let's say, the period of a pendulum. And then they brainstorm on other sticky notes factors that can affect that pendulum's period. So it could be things like the length of the string, the material, the mass at the end, the angle it's pulled back. And then from there, they choose one of the outer sticky notes to be their independent variable, and that first sticky note becomes their dependent variable. From there, students can plan out their own experiments. It's pretty easy for them to do it at this level, and just keep in mind they need to have all of those other sticky notes kept as their controlled variables. Another way to keep your students engaged is with doodle notes. Students love these. It's so great to break the monotony of regular notes and textbook work. And when I offered my students these choice boards, and I think every single choice board had a doodle note on it, students overwhelmingly chose to do the doodle note as one of their activities. They love it, they were so creative with it, and to submit them, I just had the students take a picture of them, which was pretty easy. Tomorrow I'm doing a whole session on how to use doodle notes, their brain benefits, and how to actually create doodle notes in PowerPoint. So I won't waste the time today. I'll tell you all about that in tomorrow's session. It's called Doodle Notes in Science, and we'll have a Q&A directly after that session. Physics is great because we have the opportunity to assess students in lots of different ways and for lots of different things, which could be overwhelming for us. But if we keep to small assessments of student learning, we can give them fast feedback and keep them engaged and keep supporting them through this difficult time. Some things that I would recommend you share with your students to give them fast feedback would be quick homework checks, entrance and exit cards, formative quizzes, so quizzes that don't count for grades. I love to do a quiz that's just a 2-question quiz on each side of the paper. That way I can quickly assess them and, if I'm lucky, hand them back to the students the very next class. Another great option is creating self-grading quizzes. So something as simple as a 10-question multiple choice quiz. If you do that in something like Google Forms, it can grade it for you, and then you don't even have to go through that time of marking it or grading it. And it gives the students instant feedback. Again, here we're looking to give the students feedback, not an actual grade. You may choose to invest your time this year in creating multiple choice quizzes. A study from the University of Illinois that often has class sizes of over 1,000 physics students was looking for a way to accurately use multiple choice questions that reflect how well students would perform in your typical problem-solving, calculation, and interview style questions. What they found was that you can do this. You can make multiple choice questions and tests and exams that reflect students' understandings. These are the tips that they provide for it. First, try to create the problem sets as a group. Now trust me, I know, teaching physics is a lonely job. You might be the only physics teacher at your school. Maybe you're the only physics teacher at your district. So I recommend joining the Physics Teacher Community Facebook group, and you can reach out there and see if other people are teaching similar courses to you, and maybe you guys can work together to create these problem sets. Their next tip is to define an interesting physics scenario. So something like a cat falling off of a ledge, or someone twirling a mass around their head on a string, or someone trying to push a box. With that one scenario, ask multiple questions related to that one scenario. And finally, make sure that your options for students exhaust all possibilities. So for example, if your question is about pushing a block on a table, you can say that the mass accelerates forward, the mass accelerates backwards, the mass does not move, but also include that the mass moves, but it does not accelerate. The velocity is non-zero and the acceleration is zero. So giving students all of those options is important to making these an accurate reflection of their work that they would have had as problem-solving calculation type work. One of the greatest changes I made was dropping smaller physics projects in favor of a 5-month epic project. Our semesters are 5 months long, so this project spans the entire course. This project was broken down by month, where in the first month we researched, the second month we were building, third month we were testing, fourth month we were analyzing, and then finally in month 5 we were reporting. The first year I did this project, we were examining a local issue. Our highway doesn't have a barrier or median, just some grass in between, cars and trucks going 120 kilometers per hour. And there's been a high incidence of crossover collisions involving transport trucks that have been very deadly. So the area has been petitioning for either a cable or concrete barrier, and my students were tasked with figuring out which one was preferable. In the first month, the students researched the cost, benefits, and drawbacks of both concrete and cable barriers. By the end of the first month, students had an idea of something they'd like to test with regards to this problem. So some students wanted to figure out what are the forces acting on the cars when they hit concrete and cable barriers at certain angles. After consulting with me, they had the green light to start building their scale models. We used the smart cards to scale down either a transport truck or a car so that they would be the same scale as the smart cards, and then students built their concrete and cable barriers to match that scale. I actually found the engineering diagrams online, so these were quite accurate. It was great in class being able to pour concrete and build. It's just so nice when physics is so hands-on. The students absolutely loved it. Month 3 involved testing. So here we used the smart cards and SparkView, and we were getting all sorts of data. It was phenomenal. Students were so into this that they would even come during their lunch period just to do additional tests. It was amazing. In the 4th month, students were analyzing their results. So they were able to not only look at the cost, benefits, and drawbacks, but now actually pull some data, and they could perform calculations to figure out which type of barrier system was better for our area. Month 5 was my favorite. So in month 5, students reported their findings, and this is what really made the difference. They had an incredible audience to report to. Then we hosted a symposium at the school during class time, and it overlapped with the lunch as well. So students invited their parents, their classmates, their teachers. We also had administrators from the school and the school board come in. We had the head of the local advocacy group and even the mayor show up to talk to the students about their work, about their findings, and what we should do as a community. I think this project worked so great because it had a real local connection that students felt was important, that it deserved research, and they had a really significant audience. If students are just handing work in to you, they might not do their very best. But if students know that they're going to have an audience of their parents, of their peers, of administrators, of people outside of the school, I found that students really step up their work. The quality is phenomenal. If you'd like to do the 5-month EPIC project or 10-month EPIC project, depending on how long your course is, what I would recommend is starting with a local issue. And transportation issues seem to be pretty good to work with because there's a lot of physics there. If you can work in some societal issues and some environmental issues, that's just, the cherry on top of making a really rich problem for your students. The second project that we got into this past year was whether we should have high-speed rail in our area. And this led to students creating maglev trains and testing their aerodynamics and wind tunnels, and it was phenomenal. I highly recommend the 5-month or 10-month EPIC project in your physics course. A project my students love that doesn't take too much time but has a great impact is March Madness. Yes, I know March was madness for us, but I mean like the March Madness bracket. So one of the curriculum expectations we have in my area is for students to be able to research linear and circular motion technologies. So what I have them do is I have them each choose a technology related to linear or circular motion, and on Google Classroom they have to name it, and our rule is first named, first claimed, so it's theirs. And then students write a half-page report on why this technology has impacted society and how it has impacted society. I don't need what it is. I don't really need too much of its history. I want students to focus on one thing, the impact. So the students give half a page of work and they defend their topic. Now in class, this was great. We would actually debate and students would vote anonymously for what technology they thought should proceed to the next layer or the next level of the bracket. I don't know, I don't do sports. But students would vote on that. So for our classroom online, what we did instead was I created a Google slide with all of the half-page papers written out, and they were completely anonymous. And then students would create their own bracket. So I set this up in Google Slides and they could read through and then decide which of the two technologies was most impactful and then provide some reasoning for this. What I love about this is it's not a ton of time on the students' part, but they do get a ton of information about all of the different technologies. They may not even realize how much they're learning when they're reading through all of the candidates in the March Madness bracket. Dr. Peter Liljedahl from Simon Fraser University in Vancouver wanted to study how to best foster thinking classroom behavior. So he was looking at how to best form groups for problem solving. Now here's the neat thing. You would think maybe heterogeneous groups or maybe homogeneous groups would work well in a math classroom, which really reflects a lot of what we do in physics. In fact, what they had found was completely random groups worked best. So what I do is I actually write out all of my students' names on blank playing cards. I deal them out, and that forms our groups. Oftentimes I'll let the students do it too. From this study, they found that student engagement and enthusiasm increased, social barriers decreased. How awesome is that? Students shared more knowledge, and there was a decrease in the dependence on the teacher for answers. And after 3 weeks, students were agreeable to work in any group. That's so awesome. I love this study. The same professor, Dr. Peter Liljedahl from Simon Fraser University, did research on the surfaces on which students solve problems. He found that vertical, non-permanent surfaces like whiteboards were best for students for solving problems. The neat findings from his research were that students demonstrated more thinking classroom behavior, persistence, discussion, participation, and knowledge mobility compared to all other types of work surfaces. Now, this isn't really surprising when you think about it, because when students are up and active, they're more likely to get started on a problem. The same thing too, when students know that what they're working on isn't permanent, like they're not working in permanent marker or pencil or pen, that they're more likely to get the problem started. So whiteboards are great for this. Something I like to do in my classroom in those random groups is have 2 people solve a problem together on a whiteboard. The wonderful thing here is that you can just be meandering around the classroom, listening to what the students are saying, and you get a great idea of what students know what they're doing, if students don't know what they're doing, who takes the lead in the group, who needs help, and what are the common misconceptions across your classroom. So if you're looking for something to add to your classroom this year, I would highly recommend whiteboards and maybe getting a whiteboard marker for each student so that they're not sharing. This year might be the year that we want to take physics outdoors. So here are some ideas for bringing your class outdoors, whether it's at their own homes or just outside your classroom. You can have students measure average speed and average velocity on the school's track. A really fun one to do is determining what percentage of vehicles speed in front of your school. Catapult launches are always such a hit. Treasure hunting using vector directions. My favorite lesson of all time is taking the students out, giving them bubble blowers, and then teaching thin film interference in sidewalk chalk. Launching bottle rockets, and then circular motion is great outside. You can swing a cup on a plate, you can attach your smart carts to a string and swing those around and collect data. It's just fun to get outside, and it really helps to give some novelty for your course. If you've been teaching online already, you know that creating videos can take an incredible amount of time, and it might be wise for us to lean on the efforts of those that have already done the work. My favorite video creator for physics content is Flipping Physics. He is incredible, and there's research to support this. Dr. Micheline Chi of Arizona State University and her colleagues studied why students learn more from video that include dialogue rather than just monologue or lecture. Their research found that students tend to solve problems more instead of just copying them when watching videos with dialogue. Students benefited from someone being tutored. So in this case, if someone gets the answer wrong in the video, that's an important lesson for the students. When incorrect statements were made, students could get additional clarification without them having to make that error themselves. Students tend to imitate the tutees behaviors. So if in the video the students were asking questions, the students who are watching actually ask more questions in class too. They actually imitate the behavior that they're seeing. Here are some great online creators of physics videos that I'm sure you and your students will love. If you're doing labs online, you'll definitely want to look into these online simulations. Many of them are free, some require a subscription, so you can find which ones you like best, often with a free trial, and then ask your school to cover the cost. Here are a couple of apps that your students can use to collect their own data on their phones. Thank you for being with me here today for Flexible Physics. The Q&A for this session is tomorrow after Doodle Notes in Science, and I'll be giving away 3 workbooks for some lucky teachers. I hope that you join me also for the Doodle Notes in Science session. Going forward with this crazy year, I hope that you take care of yourself, that you do what's best for you and your students, and you lead with compassion. I hope that you'll reach out on social media and join the Physics Teacher Community Facebook group, because we all know how lonely it can be being a physics teacher. We're here for you. I believe in you. Have a great year. Thank you so much.